Today, we're diving into a really groundbreaking study from Google Research and DeepMind that just might flip everything we think we know about building AI teams. It tackles a core assumption in AI that when you're dealing with intelligent agents, more is always better. But is that really true? Let's find out. Think about it. When you've got a really complex problem, what's the first thing you want to do? You assemble a bigger team, right? And in the world of AI, that logic seems to translate perfectly. More AI agents should equal better, faster, smarter results. It makes sense. But what if that core intuition is just wrong? Not long ago, a paper made this really bold claim: more agents is all you need. So Google's researchers decided to put that to the ultimate test. They designed this massive experiment to see if that idea holds up in the real world. Let's dig into what they found. Okay, to get a real answer, they knew they couldn't just mess around with theories. They had to get their hands dirty. So they set up this huge, incredibly rigorous experiment, testing 180, yep, you heard that right, 180 different AI team setups to figure out exactly what works and, more importantly, what doesn't. So let's take a look at how they did it. First up, we've got to have a baseline, right? And that's the single agent system, or SAS. You can think of this as one AI mind working all by itself. It sees the problem, it figures out a plan, and it acts on that plan, all in one continuous loop. Super simple, super focused. The lone wolf approach. And then, on the other side of the coin, you've got the multi-agent system, or MAS. Now, this is where you have multiple AIs talking, sharing information, and trying to solve a problem together. But, and this is the big insight from this whole study, how they work together turns out to be everything. The researchers tested 4 completely different team structures. First, you have independent agents. They basically work in their own little bubbles with zero communication, and their results just get mashed together at the end. Then there's the centralized team, which is like your classic corporate structure. You've got a manager or an orchestrator telling everyone what to do. Then you have decentralized teams, where all the agents debate directly with each other, kind of like a creative roundtable. And finally, hybrid models, which mix a bit of that central manager style with some peer-to-peer chat. This variety is so important because it lets them see which structures are best for which kinds of problems. And to make sure these findings were solid, they didn't just test them on one type of problem. No, they threw the kitchen sink at these AI teams. They had them do financial analysis, complex web browsing, planning out moves in a game world, and even running common business tasks. 4 totally different, really challenging arenas. All right, so they ran all the tests, they collected all the data, and the results? Well, they were definitely not what anybody was expecting. The whole idea that more agents are always better wasn't just a little bit wrong, it was spectacularly, fundamentally wrong. Just look at this. The difference is night and day. For financial analysis, a task that you can easily break down into smaller, parallel jobs, the multi-agent teams were geniuses. But for sequential planning, where every single step depends on the one that came before it, adding more agents was an absolute catastrophe. I mean, let that sink in for a second. On the right kind of task, a centralized team of AI agents performed an incredible 80.9% better than a single agent. That is a massive, massive win for AI teamwork. But, and this is the wild part, on the wrong kind of task, those very same team structures failed miserably, performing up to 70% worse. This just proves that throwing more agents at a problem isn't the solution. Sometimes it's actually the problem itself. So, what in the world is going on here? This is where the study gets really cool. The researchers didn't just stop at observing what happened, they went deeper to figure out why. And they came up with 3 core principles that perfectly explain when an AI team is going to soar and when it's going to crash and burn. Okay, let's break these down. First, there's the coordination tax. Just like with humans, managing a team takes time and energy. That overhead can actually cancel out the benefits of having more agents, especially if the task involves a lot of different tools. Second, the capability ceiling. If a single AI is already pretty good at a task, adding more agents is like having too many cooks in the kitchen. You get diminishing returns, and performance can even get worse. And finally, this one is so critical: error cascades. The way your team is structured, its topology, directly controls how a tiny mistake can spread like wildfire and bring the whole project down. And that last point about errors cascading, it's a really big deal. Just look at the difference the team structure makes. With independent agents who aren't checking each other's work, a single mistake was amplified a jaw-dropping 17 times. But in a centralized team, where you have that manager agent checking things, that error was only amplified about 4 times. Having the right structure isn't just a nice to have, it's a critical safety net. The researchers really summed it up perfectly here. At the end of the day, an AI team's success isn't about how many agents you have. It's about these specific, measurable trade-offs between the team's structure and the actual job you're asking it to do. This literally turns AI team building from a guessing game into a science. So, this is way more than just some interesting academic finding. This is a brand new rulebook for anyone out there building AI systems. It's a huge step away from just trying things and hoping for the best, and a move towards a principled, scientific way of doing things. And the new rule can be boiled down to this one simple idea: fit is greater than number. Choosing the right team architecture for the task at hand is infinitely more important than just piling on more agents and hoping for the best. And this all leads to probably the most powerful part of the entire study. Using these principles, the researchers actually built a predictive model. Get this, it can recommend the best possible AI team setup for any given task with an astounding 87% accuracy. That is an absolute game changer. It means developers can finally stop relying on guesswork and start making data-driven decisions about how to build their AI. And the number one factor in that decision, task decomposability. In simple terms, can you break the problem down into smaller, independent pieces that can be worked on at the same time?
Whew, that was a lot to take in. But hey, making complex stuff simple is what we do here at VibeDoc. If you want to keep your knowledge vibe high without your brain suffering a total coordination failure, go ahead and hit that subscribe button. I promise it's scientifically proven to have absolutely zero negative side effects.
And that leaves us with one final, pretty huge thought. As these incredibly capable AI teams become more and more common, this research forces us to ask a really deep question about our own future. Are we going to be the managers of these AI teams, directing them from the top? Or will we be working right alongside them as just another colleague on the team? The answer to that is probably going to shape the future of work itself.